Dear physics aspirants, right now I have the text of physics of class 12 level. The potential energy of a spring is being discussed. The potential energy of a spring force is an example of a variable force which is conservative. Figure 6.7 will provide you the information regarding the text. Figure 6.7 is here. You can see shows a block attached to a spring resting on a smooth here. A position, B position, C position. There were three positions for the springs, and the other end of the spring is attached to a rigid wall. The spring is light and maybe treated as more massless. In an ideal spring, the spring force Fs is equal to 0, as proportional to the x, y, or x is the displacement of the block from the equilibrium position x. Here you will see in these positions and the normal equilibrium positions. Here you will see the block from equilibrium positions. That displacement could be either positive or negative. The Sports law of spring is called Hooke's law and is mathematically stated as Fs is equal to minus kx. The constant k is called the spring constant. Its unit is Newton meter per meter. The spring is said to be stiff if k is large and soft if k is small. Here the summation is given. Suppose the V, that the pull of block outwards is as in 6.7 extension xm. Works done by the spring force. The calculus method kx dx. Expressions may also be obtained by the considering the area of the triangles as in the 6.7d. These positions. Note that work done by the external pulling force F is positive since it overcomes the spring force. Here you will see illustrations of the spring force with the block attached to the floor free of the spring. Spring force Fs is 0 when the displacement x of the equilibrium positions is 0. B for the spring x greater than 0 and Fs less than 0 for the compressed C. See here, you will see. For the compressed spring x less than 0, Fs greater than 0, the pole plot of Fs versus x, the area of the said triangle represents. The work done by the spring force due to the forcing signs of Fs and x, and this work done is the negative Ws minus kx square meter per second 2 by oblique 2. The same is true when the spring is compressed with a displacement x greater than less than 0. The spring force does work Ws kx c2 kx square c by 2. External force F does moved from displacement x1 work done by the spring Ws minus dx x1 xf. Thus the work done by the spring force depends only on its point, specifically if the block is pulled from x1 to allow it to return xt xi. Formulation is here. The work done by the spring force is cyclic process is 0. We have explicitly demonstrated that a spring force 1 is position dependent only on the first stated by Hooke, F as equal to minus kx. 2 does works which only depends on the initial and final positions, e.g. 617. Thus the spring force is a conservative force. 617. this 617 rules. We define the potential energy. We access the spring to be 0 when block spring system is in equilibrium for negative extension compression. Above analysis suggests you may easily verify minus dv dx minus kx the spring force if the block is mass m, figure 6.7 extended to xm released from rest, then its total mechanical energy at any arbitrary point is x.